I first visited the Riverside Iron Bridge in Manchester's Ancoats district on a cold morning in February, assuming it was a routine 19th century industrial structure. Official records state its construction began in 1874 under municipal engineer Alfred Barrow. But while reviewing an 1876 construction photograph at the Manchester Municipal Archive under magnification, I noticed something impossible. Perfectly symmetrical anchor blocks beneath the waterline, cut from single stone pieces with tolerances far tighter than the steam-powered tools of that decade could achieve. A note in the adjoining engineering journal mentioned a subterranean hydraulic chamber predating municipal work, dismissed as old foundations. Yet its geometry matched what some researchers now classify as Tartarian substructure signatures, architectural elements found across regions once labelled Tartaria on 18th century maps. The anchor blocks supporting the primary truss each measure approximately 2.4 meters by 1.8 meters and appear carved from single stone units. The edges are too sharp, the symmetry too exact. Industrial stone cutting from the 1870s typically shows irregular chisel marks or slight deviations. These surfaces remain uniform, almost machined, with tolerances I measured at less than 3 millimeters deviation across the entire face. The level of precision is striking. While kneeling beneath the span during my field visit in March, I traced my hand along the lower course and felt no transition lines, no seams, no mortar joins between what should have been multiple blocks. The stone was continuous, as if the entire foundation had been cast or carved as a single megalithic unit, a technique not documented in British engineering manuals of the period. A faint imprint caught my attention, 3 concentric circles etched into the westernmost block. The pattern was deliberate, geometric, strangely familiar. I had seen this motif while researching Central Asian architecture on an 1843 French atlas labelling vast territories as Grande Tartarie. The same circular pattern appeared on illustrations of what the cartographer described as ancient hydraulic installations across those regions. The official explanation in Barrow's construction notes attributes the blocks to necessary bridge reinforcement for canal traffic loads, but reinforcement rarely involves such impossible symmetry. Victorian engineers worked with pragmatic tolerances, functional, not perfect. This precision suggested a different standard, a different era, or perhaps a different origin altogether. A question lingered in my mind as I stood there in the cold. Why does a modest industrial bridge require megalithic precision that exceeds the documented capabilities of British engineering of the 1870s? While researching the bridge's construction timeline, I found an engineering journal attributed to Alfred Barrow, dated March 1876, preserved in the Manchester Engineering Society archive. Most entries were mundane: transport delays, weather complaints, steel supply notes. Yet one line stood out, written in different ink. The lower chamber, unmapped, appears older than the canal itself. Circular cavity suggests hydraulic purpose, though no machinery remains. The phrase "older than the canal" contradicted the fundamental assumption that this bridge was built entirely on new foundations. The Ashton Canal was completed in 1796. If Barrow encountered infrastructure older than that, he was describing something from the 18th century or earlier, a period when Manchester was still a modest market town, not an industrial centre requiring advanced hydraulic engineering. The implication that the foundations predated the canal is unsettling. When I visited the site again in April, I located the chamber's sealed entrance beneath the south abutment, exactly where Barrow's rough sketch indicated. A concrete patch, clearly added during a 1923 renovation, covered an arched opening cut from the same seamless stone as the anchor blocks. The curvature of the arch, perfectly elliptical, was not typical of British utilitarian construction. I measured the arch with a laser device. The ratio between its width and height was approximately 1 to 1.618, the golden ratio. This precise proportion appears repeatedly in what alternative researchers call Tartarian hydraulic architecture, particularly in star forts, sluice gates, and old-world exposition buildings documented in 19th century photographs. City renovation records from 1923 include a brief, curiously vague note saying sublevel filled for safety, unused cavity of unknown origin. Yet the cavity was clearly integrated with the bridge's foundational structure. Victorian engineers were meticulous in their record-keeping, documenting every deviation from plan. The absence of detail here felt deliberate, as if something had been quietly omitted from the official narrative. In an 1881 flood report filed with the Manchester Waterworks Department, I found a grainy photograph showing the bridge at its highest water exposure. A catastrophic winter flood had temporarily reversed the canal's flow, exposing infrastructure normally submerged. For a brief moment captured on a glass plate negative, the river receded enough to reveal an additional stone course beneath the known foundation, a layer that does not appear in any blueprint or engineering plan from the period from 1874 to 1876. During my site inspection in May, modern sediment covered most of what the photograph captured, but enough stone remained visible at low water to identify the same concentric circle motif. I measured the spacing of the motifs, approximately 1.2 meters apart, forming a regular grid. This spacing matches measurements I had documented on substructures in Kazan and Samarkand, structures in regions that older atlases classify under territories historically labeled Tartary. The repeated spacing is not a local oddity. This lower course raises an uncomfortable question that stayed with me during the train ride home. How do you build a Victorian bridge on top of something no one officially acknowledges? And why would engineers of Barrow's generation, men who documented everything from lumber grades to brick counts, choose to remain silent about infrastructure clearly more sophisticated than their own? A renovation document from 1952 contains a short sentence that began to trouble me. It reads, "Secondary aperture sealed, original purpose indeterminate." There is no drawing attached, no context, no explanation. So I returned to the site in June, searching the north side of the span. Beneath layers of industrial soot and moss growth, I found a circular outline approximately 70 centimeters in diameter, clearly filled with later concrete mix, its texture and color distinct from the original stone. The curvature is mathematically exact, suggesting it once held a mechanical component, perhaps a valve or pressure regulator. Victorian bridges rarely used such systems, especially on small canal crossings. Hydraulic regulators of that period were bulky, external, and made of exposed iron and brass. What would a sealed circular fitting be doing inside foundational stone, hidden from view, integrated into the structure itself? The diameter matches devices I had documented at demolished 19th century pumping stations across territories once labeled as Tartaria on early Imperial Russian maps, round insertion ports believed by some researchers to have housed pressure regulation mechanisms of unknown design. The consistency of this measurement across thousands of miles in an era before international engineering standardization defies conventional explanations. I stood there for nearly an hour as evening settled over the canal, running my fingers along the filled aperture, feeling the slight depression where something cylindrical had once been seated. The concrete was cold, smooth, anonymous. Whatever component had been removed left no trace except the void itself, a precisely engineered absence that raised more questions than any artifact could have answered. The void, more than anything else I had found, felt intentional. Someone had known exactly what to extract and how to erase it from the record. Digging through Alfred Barrow's surviving correspondence at the John Rylands Library, I noticed a peculiar absence. Letters from 1874 to 1876 discuss steel procurement, budget constraints, municipal oversight meetings, yet none mention the sub-level chamber he described in his private journal. Engineers of the Victorian era were meticulous, often obsessively so. They recorded every deviation from specifications, every unexpected obstacle. But here, in the official project correspondence, letters intended for city review and public record, the chamber simply does not exist. In a letter dated October 1875, addressed to the Manchester Public Works Committee, Barrow writes, "Lower works proceeding without issue, foundation stabilization complete ahead of schedule." That single sentence replaces what should have been pages of technical detail regarding the unexpected cavity, the pre-existing stonework, the engineering challenges of building atop older infrastructure. When I compared Barrow's correspondence to that of other municipal engineers working on similar projects in Leeds, Liverpool, and Sheffield, the contrast was glaring. Those engineers included extensive notes on soil composition, groundwater levels, bedrock depth. Some letters ran to multiple pages describing routine excavation challenges. Barrow glossed over the most anomalous aspect of the entire site with bureaucratic brevity. A quiet contradiction emerges, one that repeats elsewhere. The private journal acknowledges a mysterious pre-Victorian chamber with hydraulic features, while the official letters erase it entirely. This pattern of selective documentation mirrors what I have observed around other structures that alternative researchers interpret as Tartarian remnants. Instances where official records simplify or omit what physical evidence reveals as architectural complexity far exceeding the claimed construction period. As I compiled notes, a subtle pattern emerged. Every anomalous feature of the Riverside Iron Bridge, perfect stone symmetry exceeding period tool precision, sealed hydraulic aperture of unknown function, pre-existing substructure integrated without acknowledgement, existed in the foundational layer, not in the visible Victorian iron truss above. The visible bridge fits the 1870s narrative perfectly. It looks exactly as a modest industrial span should. Riveted iron, utilitarian lattice design, functional aesthetics, typical of the Industrial Revolution. But the hidden layer beneath, the layer Barrow mentioned once and never again, does not fit that story at all. This separation of eras, this architectural layering, matches a pattern I had documented in other cities during previous research. Moscow's Kitai-Gorod walls show similar characteristics, 16th century Russian construction atop foundations exhibiting precision stonework with no clear historical attribution. Parts of Prague's embankments reveal the same dual-layer structure. Sections of Istanbul's lower cisterns contain masonry that predates Ottoman records, built with techniques that later builders clearly did not possess. In all of these cases, archival maps from the 17th and 18th centuries reference Tartaria or Tartary somewhere in the surrounding regions, labels that appear on French, German, and British atlases, but are curiously absent from later cartography. The territories once marked as Tartaria correspond geographically to locations where this pattern of anomalous substructure repeatedly appears. While I hesitate to draw definitive conclusions, the Riverside Iron Bridge exhibits the same dual-era construction profile. The municipal engineers of Manchester in the 1870s appear to have built atop something older, integrating what they found rather than removing it, acknowledging it privately while erasing it publicly. One detail still haunts me weeks after completing the fieldwork: the elliptical arch of the sealed chamber. I measured its proportions repeatedly, checking my calculations against reference tables. The dimensions, a 1:1.618 ratio, match the golden ratio curves found in alleged Tartarian star-fort sluice gates documented in 19th century engineering surveys of Central Asia. The same mathematical signature, the same architectural grammar, separated by thousands of miles, and supposedly unrelated construction periods. Coincidence is possible, but patterns accumulate, and this one was becoming difficult to dismiss. The official record states that the Armitage Bridge in Leeds was completed in 1874, designed by municipal engineer Thomas Hewlin Butterworth. I first encountered it in an 1875 issue of The Engineer, where a construction photograph appeared on page 14. At first glance, it seemed unremarkable, another Victorian masonry span crossing the River Erie. But the longer I examined the plate under magnification at the British Library, the less ordinary it became. The stones forming the central arch were cut with precision that suggested machine tooling beyond what the period documented. The archivist's pencil notation in the margin claimed hand-set blocks, yet the curvature was mathematically perfect. I measured the arc deviation using digital imaging software and found less than 2 mm variance across the entire span. Victorian masons were undoubtedly skilled, producing impressive work throughout Britain's industrial cities, but no surviving quarry records describe equipment capable of achieving such uniform perfection in large-scale masonry. A second detail troubled me more. The scaffolding visible beneath the arch was sparse, too sparse to support blocks I estimated at several tons each based on known limestone densities. Even accounting for temporary supports not captured in the photographic frame, the geometry of the construction process contradicted the expected engineering sequence. How were stones of that mass placed with such precision using the wooden derricks typical of the 1870s? In the lower left corner of the photograph, barely visible in the plate's damaged emulsion, was what appeared to be a basal hydraulic relief channel, a feature not typical of British masonry bridges but documented in structures some alternative researchers associate with Tartary water distribution systems. The channel's geometry, even in the photograph's degraded state, showed the same elliptical proportion I had measured at the Riverside Iron Bridge. Butterworth's journal offered little clarity. Most entries were routine, weather delays, material deliveries, worker disputes, but one line dated August 1873 noted that workers removed the previous foundations of unknown age and that stone composition was inconsistent with local geology. Unknown age. Inconsistent geology. Two phrases that should have prompted extensive documentation, yet no further explanation appears in any subsequent entry. City records claim the western reinforcement works beneath Armitage Bridge were added in 1896. I located the renovation plans in the Leeds Municipal Archive. The drawings were surprisingly sparse, showing only superficial reinforcement beams that did not explain the heavy excavation budget, £840, approximately £100,000 in today's currency. When I compared the official 1896 blueprint to a later inspection photograph from 1912, I noticed something quietly disturbing. The inspection image showed 3 sealed sub-arches beneath the main span, arched cavities that did not appear in the original 1874 construction plans or in the 1896 reinforcement drawings. These cavities had been filled with dense mortar, as if concealing chambers rather than merely stabilizing voids. The stone around these sealed arches displayed wear patterns inconsistent with 19th century construction. The surfaces looked older, weathered in a way that suggested centuries of exposure rather than decades. I arranged a site visit in August and received permission to examine the accessible sections. Running my hand along the exposed stonework, I could feel the tooling marks were unlike Victorian chisel striations. These were micro-striated, almost polished, suggesting stone shaping techniques not documented in British engineering literature from the 1800s. A maintenance note from 1912 by Leeds City engineer Harold Marsden added further contradiction. noting that sub-chambers were inaccessible due to fill material and that prior engineering was unknown. I recommended that the chambers remain sealed pending future assessment. The phrasing prior engineering echoed descriptions I had read in colonial-era surveys of older structures across Central Asian territories, once labelled Tartaria. What troubled me most was the repetition of a feature I had already encountered in Manchester. A discrete circular aperture, approximately 65 centimetres in diameter, was set into the northern foundation stone. It was blocked with concrete, but the socket's precision was unmistakable. I had seen similar apertures documented in photographic surveys of demolished structures in Kazan, Samarkand, and Bukhara, all cities located in regions historically mapped as parts of independent Tartary. Different continents, different river systems, same geometric standard. The original 1874 construction contract referenced the removal of pre-existing piers of indeterminate age. The phrase felt deliberately vague, bureaucratically neutered. No measurements were provided, no drawings accompanied the text. No mention of the original builders or construction period appeared anywhere in the file. This omission stood in stark contrast to other bridge projects of the same era. When Glasgow constructed the George V Bridge in 1870, city records meticulously documented the removal of a medieval stone crossing, including sketches, masonry analysis, and historical notes tracing its probable 14th century origin. Leeds engineers, by comparison, simply noted pre-existing piers and moved on as if the infrastructure they dismantled was beneath historical consideration. As I researched deeper, I found a map dated 1786 in the Royal Geographical Society archive depicting the broader region, a faint label stretched across the northern territories covering parts of Russia, Central Asia, and extending ambiguously westward, independent Tartary. Maps from this period occasionally extended Tartary's boundaries in inconsistent ways, sometimes reaching into Eastern Europe, sometimes receding to the Urals. An 1874 contractor invoice included a cryptic line about removal of non-conforming stone fixtures. 4 men, 3 days, £12. Non-conforming to what standard? The stone fixtures themselves were never photographed, never catalogued, never described beyond that single terse notation. I closed the archive folder feeling a familiar unease. The official narrative was tidy, structured, and historically reassuring. Victorian engineers built a bridge to serve an industrial city's growing needs. But the physical evidence felt older, more sophisticated, and disturbingly familiar, echoing architectural principles I had only encountered in regions once marked on maps as Tartarian territory. During a September research trip to examine similar bridges in Birmingham and Sheffield, I found the pattern continuing. The 1875 Garrison Bridge in Sheffield displayed the same foundational layering, visible Victorian ironwork atop older, more precise stone architecture. A renovation photograph from 1903 showed workers sealing a sub-level chamber of uncertain origin with concrete, the exact phrasing used in Leeds and Manchester records. The Birmingham archive yielded an 1868 engineering report describing inherited stone channels beneath what became the Constitution Hill Bridge, channels that predated municipal excavation and were left undisturbed due to structural integrity concerns. Inherited, predated, unknown origin, uncertain. These words appeared repeatedly in documents separated by cities, decades, and different engineering firms, yet always describing the same phenomenon: older infrastructure integrated into Victorian construction, acknowledged privately but erased publicly. The geographical pattern also demanded attention. When I plotted the bridge locations on a historical atlas, they clustered along waterways in regions that 18th century French and British maps occasionally labelled Tartary, territories where the label Tartary appeared and disappeared inconsistently across different cartographic editions, as if the mapmakers themselves were uncertain where those boundaries lay. I spent an evening comparing my field measurements to published studies by alternative researchers who argue for a lost Tartarian civilization. The architectural signatures matched with uncomfortable precision. The 1 to 1.618 elliptical ratio, the 1.2 meter spacing of foundation markings, aperture diameters of 65 to 70 centimeters, and the seamless, megalithic stonework. Every measurement I had taken independently appeared in their databases, corroborating observations they had made across Russia, Turkey, Central Asia, and now apparently industrial Britain. The deeper question, why Victorian engineers would systematically conceal older infrastructure rather than claim credit for discovering it, remained unanswered. But the evidence pattern was becoming difficult to rationalize away. These were not random construction quirks. They represented a coherent engineering system, globally consistent, predating the Industrial Revolution, and quietly integrated into structures we have been taught to see as entirely Victorian achievements. A network some researchers call Tartarian. What troubled me most as I stood there was not the architectural sophistication, it was the systematic erasure. The collective decision to seal and forget rather than document and celebrate. By November, my research had expanded beyond British bridges to examine European infrastructure exhibiting similar characteristics. The pattern of sealed chambers, precise sub-foundations, and systematically erased older architecture appeared with striking consistency across the continent. What began as a study of Manchester's modest iron bridge had transformed into something more troubling, the recognition of systematic architectural erasure. In Prague, the 1876 reconstruction of the Mainz Bridge revealed pre-existing stone vaulting of exceptional quality. According to a Czech municipal report, vaulting subsequently filled with rubble and never documented in final construction plans. In Budapest, the 1896 renovation of the Széchenyi chain bridge involved sealing lower hydraulic passages predating known Ottoman construction. In St. Petersburg, routine maintenance of the 1850 Blagoveshchensky Bridge exposed foundational masonry inconsistent with imperial engineering standards. Each case followed the same narrative structure: discovery during construction or renovation, brief acknowledgement in internal documents, systematic exclusion from public records, and permanent sealing with concrete or fill material. The consistency of this response pattern across different nations, different political systems, and different decades suggested something more than coincidental bureaucratic practice. The architectural signatures remained identical, regardless of location. Elliptical arches maintaining golden ratio proportions, circular apertures ranging from 60 to 75 centimeters in diameter, spacing intervals of 1.2 meters in foundation grid patterns, seamless megalithic stonework showing no mortar joints. These were not stylistic preferences varying by region, they were engineering standards, globally uniform, suggesting a level of international coordination impossible for the claimed construction periods. What struck me most forcefully was the timing. The systematic sealing and documentation erasure intensified between 1870 and 1920, precisely the period when industrial modernization accelerated, when cities expanded rapidly, and when older infrastructure would have been most vulnerable to demolition or modification. It was as if a deliberate effort had been made to remove, conceal, or normalize the architectural evidence before it could be properly studied. Alternative researchers focusing on Tartarian theories have long argued that the late 19th century represented a systematic reset, a period when older advanced infrastructure was destroyed, repurposed, or buried beneath new construction, with its origins deliberately obscured. The archival evidence I was accumulating did not prove that claim, but it certainly did not contradict it. The pattern was undeniable. Older, more sophisticated engineering was systematically integrated into Victorian construction while being simultaneously erased from historical memory. Standing in the Budapest archive on a cold evening in December, reviewing yet another document describing sealed chambers of indeterminate age, I felt the full weight of the investigation's implications. This was not about architectural curiosity anymore. This was about infrastructure, functional, engineered, globally coordinated infrastructure that predated our accepted timeline for such technological capabilities. And every municipal engineer who encountered it between 1850 and 1920 made the same choice: seal it, build over it, and mention it as briefly as possible before moving on. In the final phase of the investigation, I returned to the original sites, Manchester, Leeds, and Sheffield, not to search for new evidence, but to re-examine what I had already documented through the lens of accumulated pattern recognition. What I had initially dismissed as isolated anomalies now formed a coherent picture, troubling in its implications. The Riverside Iron Bridge in Manchester, where this investigation began, no longer appeared to be a Victorian structure incorporating random older foundations. It began to look like Victorian ironwork, carefully fitted atop a pre-existing hydraulic system, a system that had been functional, purposeful, and part of a larger infrastructure network. The sealed chamber Barrow mentioned was not an abandoned cellar. It was a node in what may have been a water management grid extending beneath the industrial city, built with engineering precision that exceeded anything documented in the 1870s Britain. The Armitage Bridge in Leeds revealed similar characteristics upon re-examination. The three sealed sub-arches were not construction errors or natural voids. They were chambers, deliberately built, connected by conduits that had been marked as existing. The circular apertures were not decorative flourishes. They were component housings, sockets designed for mechanical or hydraulic fittings that were methodically removed before the Victorian superstructure was completed. Comparing the Manchester and Leeds sites side by side, the system's logic became clearer. Both bridges were built over river crossings. Both incorporated older foundations exhibiting identical architectural signatures. Both included sealed chambers and removed components. Both were constructed during the same narrow window from 1874 to 1876, when British municipal engineering was expanding rapidly and encountering older infrastructure it could not explain. The pattern suggested purpose. These were not random remnants, but nodes in what researchers of Tartarian architecture describe as continental-scale water management systems, networks of channels, chambers, and pressure regulation mechanisms designed to distribute water across vast distances using gravity, siphon principles, and hydraulic pressure in ways that would not be theoretically understood until the early 20th century. I examined my field photographs and measurements one final time. The golden ratio elliptical arches, the 1.2 meter spacing intervals, the 65 to 70 centimeter aperture diameters, the seamless megalithic foundations. Every measurement matched documented Tartarian signatures from structures in Kazan, Samarkand, and Istanbul, cities separated by thousands of miles, supposedly built by different civilizations in different eras, yet sharing identical engineering mathematics. The uncomfortable realization settled over me gradually. Victorian Britain did not build these bridges from nothing. Victorian engineers adapted, sealed, and concealed infrastructure they found, infrastructure that predated their era, exceeded their documented capabilities, and contradicted the historical narrative they were constructing about human technological progress. The question of attribution remained unresolved. I could not prove with certainty that these systems were Tartarian. The term itself is contested, referring to civilizations that appear on maps but disappear from later historical accounts. But the architectural DNA was undeniable. These structures shared engineering principles with buildings across territories once labeled Tartaria. They were built with a level of precision that should not have existed in the claimed construction periods, and they were systematically erased from public memory during the exact historical window when industrial civilization was rewriting its own origins. What troubled me most as I compiled the final report was not what I had found. It was what remained sealed. Chambers beneath hundreds of bridges, channels under city streets, systems deliberately filled with concrete and left to be forgotten. The Victorian engineers knew what they were building upon. The question that haunted me was simple and more disturbing. What did they find down there that made them choose silence? I returned to the Riverside Iron Bridge on a January morning, standing in the same position where this investigation had begun 11 months earlier. The lattice ironwork above remained unchanged, solid Victorian engineering, functional and unremarkable. But beneath it, hidden below the waterline, lay the seamless stone foundations I had measured and documented, too precise, too old, too sophisticated for the official narrative that claimed 1874 as their origin. The sealed chamber Alfred Barrow mentioned in his journal remained closed, its entrance covered by the 1923 concrete patch. The circular aperture on the northern foundation stayed filled, deliberately emptied of whatever component it once held. The three concentric circles etched into the anchor block were still visible when the water level dropped, faint markers of an engineering system no Victorian document adequately explained. Across England, across Europe, the pattern continued. Sealed chambers beneath bridges, removed components from older foundations, hydraulic systems predating documented construction, architectural signatures repeated with mathematical precision across continents in an era before international engineering standardization could explain such consistency. Every anomaly I had investigated echoed the same quiet contradiction. What we have been taught to see as Victorian innovation may have been Victorian adaptation, building upon, sealing within, and finally, forgetting infrastructure inherited from an earlier, more sophisticated network. The evidence accumulated into pattern. The pattern suggested system. The system implied civilization. And the civilization, the one that built with megalithic precision, engineered continental-scale hydraulic networks and left mathematical signatures in stone foundations from Manchester to Samarkand, appeared on 18th century maps labelled Tartary before disappearing from later historical accounts. I could not prove that attribution with certainty. The archival gaps were too systematic, the documentary silence too complete, the physical evidence too fragmentary after a century of demolition and sealing. But the alignment was undeniable. Every measurement I had taken independently matched what Tartarian researchers had documented. Every sealed chamber I had found echoed their descriptions. Every contradiction I had encountered in official records paralleled their arguments about systematic historical erasure. The Victorian engineers who built these bridges faced a choice when they encountered older infrastructure: acknowledge its sophistication and question their own civilization's presumed technological superiority, or integrate it quietly, seal it permanently, and document it minimally. The archival record suggests they chose the latter. Barrow's private journal acknowledged what his public letters erased. Butterworth noted unknown age in passing before moving on. Holdsworth marked existing conduits on blueprints without questioning their origin. Across Britain, across Europe, the response remained consistent: build over it, seal it, forget it. What remains is not proof, but invitation. The sealed chamber beneath the Riverside Iron Bridge is still there, accessible only through concrete and bureaucratic prohibition. The hydraulic passages under the Armitage Bridge remain filled, unexplored, officially non-existent. The circular apertures, thousands of them scattered across bridge foundations throughout Europe, stay empty, their removed components lost to history. The photograph that began this investigation, the 1876 construction plate showing anchor blocks of impossible precision, sits in the Manchester Municipal Archive, available to anyone willing to look closely. The measurements are reproducible, the contradictions are documented, the pattern extends across continents. And beneath the industrial cities we inherited lies infrastructure we did not build, engineered by a civilization we have chosen not to remember. I stood on that bridge one final time as winter light faded over the canal. The iron lattice above cast geometric shadows across water that flowed, as it always had, over foundations too perfect to be Victorian, too old to be documented, too systematic to be accidental. The investigation was complete. But the architecture remained, sealed and silent, waiting beneath the weight of a history that had written it out of existence. What we call Victorian engineering may have been Victorian inheritance. And the inheritance, precise, hydraulic, globally coordinated, bears the mathematical signature of an architectural network that 18th century cartographers labeled Tartaria before the 19th century decided such a civilization had never existed at all. The question lingers in the archive, in the sealed chambers, in the removed apertures, in the foundations too advanced for their attributed age. If we did not build it, who did? And why have we spent 150 years pretending we did?